So you recognize this as a limit function of the slope of the tangent line at a point. Just to review, if you have the rate of change between 2 points, that is the slope of the secant line. And the instantaneous rate of change, what I have here, is that slope of that tangent line. And that's for all values of A as you're getting closer and closer to that point. This idea of the slope of the tangent line is so important, we call it the derivative. And this means it's the derivative with respect to the x value. And this is important because we're talking about the function. And then the derivative of that function has a notation of f prime of x. So the definition of the derivative is written as f prime of x is equal to the limit as h approaches 0 of of f plus h minus f of x all over h. And that idea behind this is this will give us a function that gives us all of the slopes of that tangent line. So the first thing that I want to do here is find the derivative using the process of the limit. And I want to find the equation of the tangent line at a given point, and this point will be at -2, 2. So to use this limit process, what I want to do is say the limit as x approaches -2. I'm using that x value as x approaches a of f of x minus f of a, all divided by x minus a. And again, we're saying that a is -2, right? This gives me my instantaneous rate of change at a particular value, at that value that I'm specifically looking at, -2. So let's plug all of that in, and you end up getting the limit as x approaches -2 of x squared plus 3x plus 4. I subtract f of a, which is going to be -2 squared plus 3 times -2 plus 4. And in the denominator, that is all over x minus a, or x minus a -2. Now let's go ahead and simplify this, and that leaves us the limit as x approaches -2 at x squared plus 3x plus 4 minus 2, all divided by x plus 2. Let's go. When I simplify that, I get the limit as x approaches -2 of x squared plus 3x plus 2 all over x plus 2, which is equal to the limit as x approaches -2. I'm going to factor the numerator, and I get x plus 2 times x plus 1 all over x plus 2. The denominator cancels, and now I can go ahead and use direct substitution. and get the limit as x approaches -2 is x plus 1, and direct substitution gives me the fact that that is equal to -1. So what is all of this telling me? All of this is saying that at my graph, you don't have to graph this to answer the question, but it helps to visualize what's going on. All right, this is the graph of my function. The point that I'm looking for is -2, 2. That was the beginning portion I have. And I want the slope of this line. That is what the limit process told us, and the limit process said that the slope, all of this at -2, so that slope of this line is the slope of the tangent line is -1. Now, the question that we asked in the beginning is, what is the equation of this line? To find the equation of this line, we do the same thing we would normally do back from, and to find an equation of a line, we use the point slope form, which is y minus y1 is equal to mx minus x1, where your given point is the one that we have on our function, that point from the beginning, which was -2, 2. We found what slope was, so I just plug all of that in. So plugging all those values in, we get y minus 2 is equal to -1 times x minus a -2 gives us a +2. Move everything over and simplify. I get y is equal to -x. And that's because when I go through and add that 2, that -2, that's going to be -x minus 2. And those 2's will cancel out. So the equation of the tangent line at this one particular point is y is equal to -x. All right, let's do one more. So if I have f of x is equal to the square root of x minus 1, I want to, again, find the equation of the tangent line. And this time I'm going to start off with a graph. So I'm going to go ahead and graph the function, the square root of x minus 1. So our function is going to, so our function starts at 1, and I know it goes through a point 5, 2. That was given to us. So my square root function looks like this, and I am looking for the equation of this line. Now, step 1 is to find the slope of the tangent line. And we're going to use that doing the limit process of the derivative at a given point. So let's take a look. What that means we're doing is we are finding the limit as x approaches 5 of f of x minus f of a, and I want to divide all of that by x minus a. So that leaves me with the square root of x minus 1 minus the square root of 5 minus 1 all over x minus 5. Simplifying this in the numerator, I get the square root of x minus 1 minus the square root of 4 which is actually just 2, all over x minus 5. Oh, and remember, this is the limit as x approaches 5. Now, what I need to do with this here is rationalize it, because if I use direct substitution, I'll get a 0 in the denominator. So I want to take that x minus 1 minus 2 and x minus 5 and rationalize it, rationalize the numerator. So we're going to multiply both the top and the bottom by x minus 1 plus the square plus 2, and then the square root of x minus 1 plus 2. When I multiply all of this out, the limit as x approaches 5, in the numerator, that's the difference of 2 squares. So in the numerator, you are left with, so you are foiling all of this out, both in the numerator and the denominator. I am going to do this one out. What that would leave you with is that would be x minus 1 quantity squared, and then that's going to be minus 2 times the square root of x plus 1 plus 2 times the square root of x plus 1 minus 4. All of this will go away, and the square root of anything squared is just equal to itself. And in the denominator, I'm just going to keep this as x minus 5 times the square root of x minus 1 plus 2. Now, when simplified, that goes directly to x minus 1 minus 4 in the numerator. Now, I change that, that becomes x minus 5. And now I can go ahead and cancel that x minus 5 out. It reduces to equal 1. And now I have the limit as x approaches 5. I can use direct substitution for my x minus 1 plus 2. And I am left with the fact that that is equal to 1 over the square root of 5 minus 1 plus 2, or 1 over the square root of 4 plus 2, or the square root of 4 is just equal to 2. So that gives me 1/2. Now again, what does this 1/4 represent? Well, let's go back up to the top for a second. And what this is telling me is that this is the slope of this tangent line. That means m of this tangent line is equal to 1/4. But that's not what the question asked me. The question wanted what the equation of this line is. So plugging that back into point slope form, y minus y1 is equal to m x minus x1 gives me y minus 2 is equal to 1/4 of x minus 5. Which, to put it into slope-intercept form, gives me y is equal to 1/4 x minus 5/4 plus 2, or the slope of that line is, which is 1/4 x. 2 is rewritten as 8/4. So that gives me 1/4 x plus 3/4. So that will be the final answer for that question.